is 8 massive signals having 2 kHz bandwidth each or time division multiplexed using PCM. The error in sampling amplitude cannot be greater than 1% of the peak amplitude. Determine the minimum transmission bandwidth required if the Rayson cosine pulses with roll-off factor 0.2 are used. The sampling rate must be at least 25% above the Nyquist rate. That is, Fs is 1.25 into 2 FM, whereas FM is 2 kHz. Hence it is going to be 5 kHz. So there are number of signals are 8. So the amplitude cannot be greater than the 1% of the peak amplitude. The error is going to be delta by 2, that is 2 AM by L. 2L is nothing but 1 by 100 AM. So 1 by L equals to 1 by 100, which gives L is 100, nothing but N equals to 7 bits per sample. See, after getting the number of bits per sample, what we have to do is we have to decide the bandwidth. Bandwidth is nothing but 1 by 2t 1 plus alpha. Here mainly 1 by 2t is nothing but NFS by 2 into N, which is nothing but 7 into 5 into 10 power 3 divided by 2 into 8. Okay, alpha is 0.2. After substituting into the bandwidth equation, we will get as 168 kHz, which is option B is correct. Which of the following is don't care combination and the Boolean expression, which is a simplified version of expression? Here E equals to 0. Okay, A, B, C, D, A, B, C, D. See, here the don't care combinations are this. If we write the expression for these three don't care conditions, this you will get A, B, C. So D is the D is the only option which is not a don't care condition. Hence option D is correct. Question is, an FSK system transmits binary data at a rate of 2.5 into 10 power 6 bits per second. During the course of transmission, wide Gaussian noise of 0 mean and the post-spectral density of 10 power minus 20 watts per hertz is added to the signal. In the absence of noise, the amplitude of the received sinusoidal wave for digit 1 or 0 is a 1 microvolt. Determine the average probability error assuming coherent detection. We know that probability error in case of an FSK using coherent detection is nothing but Q of under root ED by 2 eta. Here A is nothing but 1 microvolt 10 power minus 6, eta is 10 power minus 20 watts per hertz. Here T is nothing but 1 by the bit rate 2.5 into 10 power 6. If we substitute, we will get probability of error is 4.47, which is option B is correct. Next, match the list 1 with the list 2. Here in list 1, the discrete time signal is given, x of n is given. We in list 2 z corresponding z transform is given. So we know that alpha n u of n is nothing but 1 by 1 minus alpha z inverse, whose ROC is mod z greater than mod alpha. Hence A is nothing but a 2. Now comes to B. see minus alpha n u of minus n minus 1 is having the same transform as a alpha n u power n, except that its ROC is less than alpha, which is nothing but b is 3. Now comes to c, minus n alpha n u power minus n minus 1 is nothing but a differentiation of this one, alpha z inverse 1 minus alpha z inverse mod z less than mod alpha. Hence option C is option 4. Comes to D, remaining option is 1. Hence A, B, C, D 2, 3, 4, 1. So the following relationships holds good. A is the non-minimum phase filter. Here the definition for the non-minimum phase is nothing but, here in non-minimum phase all the zeros or some of the zeros can be in the right hand side of the S-plane, but all the poles must be in the towards the left half of the S-plane. Whereas in minimum phase filter, all the poles as well as all the zeros must be in the left half of the S-plane. Comes to all pass filter. In case of all pass filter, poles and zeros are exactly a mirror replication. Means for a stable system, the poles must be in the left half of the S-plane. Means the zeros must be in the right half of the S-plane for all pass filter. So that we can arrange like this. After knowing to the definition of the A, B, C, we came to know that option A is the correct answer. Question is a real valued signal x of n whose power is 5 and its real power is 1 by 2 whole power mod n, and the power in output is, we know that total power is nothing but power in output plus power in even part. Here 1 by x naught of n whole square, n is minus infinite to infinite, n is minus infinite to infinite, xe of n whole square. So even power is nothing but minus 1 plus 2e power n equals to 0 to infinity 1 by 2 2 power n, which is 5 by 3. So p naught is nothing but five minus 5 by 3, which is 10 by 3. Hence option B is correct. Question is, a certain DAC has the lowest and highest of resistances 1k and 8k respectively. If the bit length of the converter is increased by 2, what would be the additional resistor and their values? Now here 2 power n minus 1 into R is 8 kilohertz and 2 power 0 R is 2 kilohertz. Means 2 power n minus 1 is equals to 4, that is 2 square. N minus 1 is 2, n is equal to 3. If the bit length is increased by 2, then n dash is nothing but n plus 2, that is 5. The number of additional resistors will be 2. Then the values would be 16k and 32k, hence option B is correct.